Alright, our goal is to use integration by parts to evaluate integrals. What we want to remember is that we already know how to integrate. For example, we're going to start with this basic function e to the x. We know that the integration of e to the x dx is e to the x plus c. Well, what if we have something more than x? So let's say instead we had the integration of x times e to the x squared. Here's an example of one where we would have to use substitution. We would let u equal x squared. We would take the derivative of u, which would be 2x dx. We look back into our original problem and we see that we have just an x dx, whereas here we have a 2x dx. So to get rid of that extra factor of 2, we multiply by 1/2. So we have 1/2 du will equal x dx. Now we can make our substitution. We rewrite our original problem, 1/2 the integration e to the u du. Well, that will be 1/2. The integral of e to the u is just e to the u plus c, because this is an indefinite integral. Take u out, put the x squared back in, which is what we set u to be, and we're done. Remember our check. Our check would be to take the derivative. The derivative of e to the x is e to the x. So it would be 1/2 e to the x squared. But now, here we have to use the chain rule because x squared also has a derivative. We'd have to multiply by 2x, the derivative of x squared. Derivative of constant would be 0. 1/2 of 2 is 1, so we're left with x e to the x squared, which is exactly what we started with, so that checks. But now, what if we started with a problem like this? What if I had the integral of x e to the 6x dx? Well, let's think. Here we have a product, so we can't just integrate the way it is. We would have to use u. Our best choice for u would be the 6x. So if we go and let u equal 6x, du would equal 6 dx. When we try to make a match here, we could replace this with e to the u, but we have this x left over. We don't have an x down here. So this substitution won't work. In other words, we'd be left with, we would take that 1/6 and x e to the u du. We can't integrate when we have a mix of two different variables. We also can't integrate a product. Well, we can do this using a method we're going to call integration by parts, and that's what we're going to look at today. So by the end of class today, you should know how to integrate in a problem like this. Okay, to kind of make sense of this formula for integration by parts, I want you to go back and think about a derivative of a product. So if we had a function f times a function g, and we wanted the derivative of that, we use this prime notation that we've used before for a derivative. Remember, the derivative of a product was first, which would be f, times the derivative of the second, plus second times the derivative of the first. Product rule. Now we want to go backwards and connect this to integration. So if I now integrate this, and I want to integrate both sides. Remember, an integration or an integral and a derivative are inverse operations. They basically cancel each other. So it's like these will cancel. So we're left on the left with just FG. In other words, our original product equals, over here we're still going to have what we started with. And now what we're going to do is we're going to take this equation, we're going to take this side and move to the left by subtracting it. Whatever we do to one side of an equation, we got to do the other. So we end up with f times g minus the integral of f prime g will equal the integral of f g prime. That's actually where the integration by parts formula comes from. Okay, so if we have the integral of some function times the derivative of another function, it'll be equal to the product of the two functions minus the integral of the derivative of the first function times the original second function. We're going to write this in different notation now. In other words, let's say that u is this original function f of x. Then du will equal f prime of x. And then let's say v is this other function, g of x. Then dv will equal g prime of x. So now if we rewrite what's up here in red using u, du, v, and dv, we would get the following. We'd have the integral of u dv will equal f is our u, g is v, minus the integral f prime is du and g is v. And this is the way you'll normally see that integration by parts formula. So just wanted to explain where it came from. Okay, so now let's go back to our original problem that we couldn't do, which was the integration of x e to the 6x dx. Here's our integration by parts formula. So when we run into a situation where we try to make a substitution and we end up with an extra x, we try the integration by parts. And what we're going to do is we're going to say that u is our x. Then the e to the 6x is our dv. Alright, well what we need is we need to find du and we need to find v. Well, du is the derivative of u. Derivative of x is 1 dx. And if we have derivative of v, to find v, we would integrate dv. So we need to integrate dv the integration of dv would give us v. Well, the integral of e to the 6x would just be 1/6 e to the 6x. Alright, now I have everything I need to do my integration by parts. So the integration of x e to the 6x dx is, here's my u, and here's my dv. So I'd end up with, it's going to equal u times v, which is x times 1/6 e to the 6x. There's my u times my v, minus the integration of v, which is 1/6 e to the 6x, du, which is dx. So now I just have to simplify this part, which would just end up being 1/6 x e to the 6x Okay, so now we need to integrate this part right here. So to integrate this, we're going to have to use basically u substitution. We'll let u equal 6x, and du will equal 6dx. When we look at this, so we have the integration of e to the u, and then dx, we have 6dx. Well, we only need a dx, so we're going to have 1/6. So it's 1/6 du. Then we still have that other 1/6 that was in the original problem. So really we're going to have 1/36. The integration of e to the u is e to the u. I'm going to take that u and replace it back with 6x, and then plus c. So I'm going to put that over here. So my answer is 1/6 x e to the 6x minus 1/36 e to the 6x plus c. And that's it.